Hello everyone, welcome back to the video. Today we are going to discuss about a topic called sequential circuits. Let's get into the topic. Introduction to sequential circuits. Let's see what I mean by sequential circuits. Sequential circuits are a type of digital circuit that stores and processes information over time. These circuits use feedback to remember past inputs and produce outputs based on both current and previous inputs. Sequential circuits are essential components in modern electronic devices. We can see the block diagram of sequential circuit. Types of sequential circuits. There are two main types of sequential circuits, synchronous and asynchronous. Synchronous circuits use a clock signal to synchronize the operation of the circuit. Asynchronous circuits do not require a clock signal and operate based on the completion of previous operations. Types of sequential circuits depends on the times at which storage elements observe their inputs and storage elements changes state. Synchronous behavior defined from knowledge of its signals at discrete instances of time. Storage elements observe input and can change state only in relation to a time signal, clock pulses from a clock. Asynchronous behavior defined from knowledge of inputs and any instant of time and the order in continuous time in which inputs change. If clock just regarded as another input, all circuits are asynchronous. Nevertheless, the synchronous abstraction makes complex design tractable. Flip-flops in sequential circuits. Flip-flops are fundamental building blocks of sequential circuits. They store a single byte of data using two stable states, 0 and 1. Common types of flip-flops include D flip-flops, T flip-flops, JK flip-flops, and SR flip-flops. Registers in sequential circuits. Registers are sequential circuits that store multiple bits of data. They are commonly used to store data temporarily during processing. Shift registers are a type of register that can shift data in and out serially. Counter in sequential circuits. Counters are sequential circuits used to count events or sequences of binary numbers. They can be synchronous or asynchronous, depending on the design. Common types of counters include binary counters, up-down counters, and ripple counters. State machines in sequential circuits. State machines are sequential circuits that have finite number of states. They transition between states based on inputs and current state. State machines are used in control systems, digital signal processing, and more. Finite state machines (FSM). Finite state machines are a type of state machine with a finite number of states. FSMs are used in sequential logic to control the behavior of digital systems. They often represent it using state diagrams or state tables. Melee and More machines. Melee machines and More machines are two common types of finite state machines. In a melee machine, the outputs depend on both the current state and inputs. In More machine, the output depends only on the current state. Applications of sequential circuits. Sequential circuits are used in a wide range of applications, including computer processor, computer memory units, and communication systems. They are essential for storing and processing data in a sequential manner. Sequential circuits play a crucial role in the functioning of digital systems. Designing sequential circuits. The design of sequential circuits involves specifying the states, transitions, and outputs of the circuit. Sequential circuit design often requires the use of tools such as state diagrams, truth tables, and timing diagrams. Designers must consider factors such as timing, power consumption, and reliability. Timing considerations in sequential circuits. Timing analysis is crucial in sequential circuit designed to ensure proper operation. Clocks give setup time and hold time are important timing parameters to consider. Violations of timing constraints can lead to circuit malfunction or failure. Testing sequential circuits. Testing sequential circuits is essential to ensure their correct operation. Techniques such as simulation, formal verification, and hardware testing are used to validate the circuit's functionality. Test patterns are generated to stimulate the circuit and observe its responses. Challenges in sequential circuit design. Sequential circuit design poses challenges such as metastability, race conditions, clock domain crossing. Metastability occurs when a flip-flop output remains undefined due to timing issues. Race conditions can lead to unpredictable behavior in the circuit. Conclusion. Sequential circuits are essential components in digital systems for storing and processing data. Understanding the principles of sequential circuit design is crucial for developing efficient and reliable electronic devices. Continued research and innovation in sequential circuits will drive advancements in digital technology. Thank you for watching this video.